So here is one of the application of the voltage divider circuit. We see that we have used the BJT. This is the NPN transistor, and to the base you have applied the input signal through this capacitor. The role of this capacitor is to filter out the DC present in the AC input. Then at the collector you have another capacitor, and role of this capacitor is to filter out the DC present in the output voltage VO. Now emitter is connected to the ground through the resistor RE. We know that from the transistor circuits we have seen earlier, and we have learned earlier that this resistor is called emitter degeneration resistor, that lowers the overall gain of the circuit. However, this resistor helps us to stabilize the DC operating point of this circuit, and the DC operating point of this circuit is set by the combination of resistor R1 and R2. Now RC is there to in the collector branch of the transistor, and this helps us to set the gain of the transistor. Capacitor CE is used to bypass the it is called as bypass capacitor, and it is used there to hold the DC voltage across the resistor RE, and it gets short circuited for the AC signal that is present into the circuit. Now you have voltage supply VCC, that is the DC supply, that we switched it on and the current starts flowing through the circuits, and we see that the resistor R1 and R2 are used to set the DC operating point of the circuit. So here the voltage across the R1 and R2 can be calculated. So VR2, that is the voltage across R2, can be written as the value of the resistor itself divided by R1 plus R2 multiplied by VCC. So it is simply a voltage division rule that we just applied, and I would encourage you to take a look at the voltage division module, how we actually can apply the voltage divider rule to the circuit. So now you see that you have the voltage across base and emitter, that is VBE, that is your VBE, that is the base emitter voltage, and then the voltage across the resistor RE is VRE. So you have three voltage drops in this loop. So that's the voltage across R2, the voltage across the base emitter junction, and the voltage across the resistor RE. So when you apply the KVL, that is Kirchhoff's voltage law, into the circuit, you can get the values of the voltages, and accordingly you can determine what is the voltage across each of the resistors and across the junction based on the values of the resistors and the supply voltages. Similarly, you can calculate the voltage across R1 as well. So that is nothing but applying Ohm's law, that is the current that flows through R1 multiplied by the value of the resistor R1. Similarly, you can apply the Ohm's law here as well, that is the current through the R2 and the value of the resistor R2 itself will give you the drop across the R2. So the purpose of this module was to give you the idea about how you can apply the voltage division rule to calculate the voltage across R2.